So the principle of operation continuation, and so let me draw a diagram so that you can understand easily. So this is the DC supply, and this is the switch, and this is nothing but a load. This is load, and this is a freewheeling diode. This is freewheeling diode, and in series with the load, we may connect a inductor. So this is the chopper circuit, and so during the turn off period, chopper is off condition and the load current will flows. So let me take this clearly. So this is a circuit, and if the switch is open, there is no supply from the there is no current supply from source to load. So that during the turn off period, chopper is off condition. Load current flows through the freewheeling diode, which means, so look at this one. This is the inductor. So this is the inductor. This inductor, whatever the energy stored in the inductor, will be releases in the form of negative and positive terminals to the load, and that will be continuous to the freewheeling diode. So this is what he explained in this point. During the turn off period, the load current flows through the freewheeling diode. So you may get it out during in the turn off conditions, how the current will flows in the through the load by using the freewheeling diode. That is because of the series inductor. The inductor will be connected in series with the load. And the next continuation of this one. Let me erase these things. So let me draw a clear diagram of chopper so that you can understand easily. So this is the supply voltage. So this is source, nothing but the DC, VDC or VS, and this is the switch which is connected in series with the load, and the load is connected through an inductor, series inductor. This is load, and this is a less series inductor. This is nothing but a chopper switch, and this is nothing but FD, nothing but freewheeling diode. So as a result of low terminal are short circuited by freewheeling diode, this so whatever the energy stored during the off the condition, chopper switch will be in open condition. Energy stored in inductor will be released through the load at a freewheeling diode, and this diode act as a short circuit. That's what he is explaining here. Terminals are short circuited by the freewheeling diode. Next, thus the load voltage is 0 during the turn off period. Nothing but, for example, this is the supply voltage, this is Vs, and this is nothing but V output voltage. This is on time, and this is the on time, T on time, and this is T on time, and this is the T off time. During the turn off period, the load voltage is 0, he is saying. Next point is In this manner, the DC chopper is uh, produced produced across the load terminal. In this way, the DC voltage is produced across the load terminals. And look at this one. So total time period. Total time is nothing but time period on time plus off time. Let me erase this one. So that from down, it is clear that the load voltage depends on the two factors. One is on time and off. Another one is off time. So supply voltage and the duty cycle of the chopper. So this load voltage depends upon the two factors. One is supply voltage and also duty cycle. Nothing but how much fast you are on, turn on, turn off, turn on and turn off the chopper. And since the supply voltage is constant, the voltage load voltage is governed by the duty cycle of the chopper. Nothing but if the supply voltage is constant, the load voltage is governed by the duty cycle. In other words, the load voltage depends on the two factors, that is nothing but T on and T off. And let us look at the chopper operation. Before that one, let me erase these things. So let us discuss the principle of operation of the chopper. So hence it is concluded that the average load voltage can be controlled by varying the value of turn on and turn off time. Turn on time and turn off time. The average voltage will be varied by using two factors. One is turn on and turn off time. By using the turn on time, keeping the time period constant, this is called constant frequency. I already told you there are two types of controlling. So what is pulse width modulation control, and another one is by varying the frequency. So this is by varying the turn on time by keeping the T constant. Such a system is called constant frequency. And a variable frequency system by keeping either turn on time or by varying turn off time. Either of one we can do by changing the frequency system. So V output is equal to, the equation is V output is equal to output voltage is available during the turn on time only. So during the turn on time, this is the V output is available only with the turn on time only. And with respect to supply voltage we should take. But supply is available total turn on plus turn off time. So this is nothing but a duty cycle. This is nothing but a duty cycle. So the output voltage is available during the turn on period only. During the turn on period. But if you want to take output voltage with respect to supply voltage, but the supply voltage is available during the turn on time and turn off time. That's why V output is equal to T on over T on plus T off. Nothing but T on over T. T is equal to T on plus T off into multiplied with the supply voltage, which is equal to T on by T into Vs. So this is T on by T is equal to, this is alpha, which is nothing but a duty cycle. So this alpha is called as a duty cycle. So which is equal to T on by T, where T is equal to, we know that one, T on plus T off. This is the average output voltage is equal to V output is equal to alpha into Vs. This is the average output voltage. If you want to find RMS, Vrms is equal to, simply Vrms is equal to under root of alpha under root of alpha into Vs. Simply, this is the only difference. For RMS value, average value, just alpha. For RMS value, just root times of alpha. This is the difference between RMS and the average value. Next, so let me clean this one. So simply RMS value of the RMS sorry the difference between RMS and the average value is based on the duty cycle. So if V output is equal to V alpha into Vs, that is nothing but a average value, and if you take root times of alpha into supply voltage, that becomes RMS value. Next, so look at this one, principle of chopper. So this is nothing but a switch. So in place of switch, you can use either SCR or BJT or GT. So anything we can use in place of this switch. So here SCR is used, and this is a series inductor which is connected in series with the load, and this is nothing but a freewheeling diode, which I already explained. So during the turn on of voltage, during the turning on of switch, if you turn on the switch, nothing but SCR will turn on, and diode will be reverse biased, so that this will act as a open circuit. Freewheeling diode act as a open circuit, and energy will be stored in the inductor, series inductor. Energy will be stored in the series inductor, and current will and this inductor connected in series with the load, and whatever the current will be flows through the inductor will be sent to the load, and this will be the closed path. So let me draw a diagram, switching diagram. This is supply voltage Vs, and this is V output voltage. So this is for example, this is T on time, nothing but the thyristor in on time. During this period, thyristor will be turned on, nothing but this switch will be turned on, and during this period the current will be circulated and energy will be stored in the inductor, and after certain duration the thyristor will be off. After certain duration, thyristor will be off. In such a condition, what will happen? The thyristor, nothing but switch, will be open circuited, because off time. This is during the off time, this will be open circuited. And look at this one. There is no supply to the freewheeling diode, so that this will act as a there is no supply on the freewheeling diode, so that look at this one. During the while charging the inductor, the terminals will be like this, positive and negative. So while charging the inductor, terminals will be like this. While releasing the energy, automatically it will change its orientation like this, -2 plus. While observing the energy, the terminal will be like this, positive and negative. While releasing the energy, the terminals will be like this. Look at this one. With respect to these terminals, negative is connected to the diode, freewheeling diode, and positive is connected to the cathode, and positive is connected to the anode, so that this freewheeling diode will be in forward biased. So whatever the energy which is stored in the inductor will be releases in this path. So during this turn-off period, even though supply voltage is absent, but the load current will be circulated. In this way, you can utilize the energy which is stored in the inductor, and by keeping the supply voltages off. So this is the basic operation of the chopper.